I'm going to walk you through a couple of problems having to do with levers and one having to do with an inclined plane. The expectation is that you would be able to do these similar problems if I give you a second paper, maybe the next time we meet as a class. So I would have the paper in front of you, which I will give to you, something to write with. If you'd like to have a straight edge, that might help as well. The very first problem talks about a first class lever. Just a reminder that you're probably going to want to go ahead and draw a fulcrum. Triangle works fine. And if I read ahead a little bit, it tells me that I have one arm of 2 meters and one of 5 meters. So I'm going to make one a little bit longer. You don't have to be exact. This is my 5-meter arm. This is my 2-meter arm. And the 5-meter arm is my distance in, which means this is where I'm applying the force. This would be my force in. I'm sort of pushing down on the lever. And over here, I'm trying to lift some sort of load. So this is my force out. And just a reminder, the distance in is measured always from the fulcrum to where I apply the force. And the distance out is measured from the fulcrum to where the load is located. So those are my two what we call lever arms. And the equation for ideal mechanical advantage of a lever is equal to the distance in divided by the distance out. So this would be 5 meters divided by 2.0 meters, which equals 2.5. Remember, there are no units. Meters cancel. Mechanical advantage is always given as just a number. All right, second problem. Says you have a second class lever. Remember, second class lever is much like a wheelbarrow. So I'm going to go ahead and put a fulcrum with a long lever arm. Tells me the resistance arm is 2 meters. Remember, my load is going to be somewhere in here. Always measure my resistance arm from the resistance or the load to the fulcrum. So this is 2 meters. This is my distance out. This here is where the load is. So we call this force out. This is kind of the output. This is where you're lifting the handles of the wheelbarrow. So that's my force in. And I measure from the fulcrum all the way, sort of the whole length of the wheelbarrow or the whole length of that lever arm. And that's called my effort arm. And in this case, it is asking me what that is. So that's my question mark. But it also tells me that the ideal mechanical advantage is 4. So I have some information here. So I know that my mechanical advantage is equal to 4. And that is equal to the distance in over the distance out. Now distance in, I don't have. That's this one right here. So we're just going to call that my question mark. So that divided by 2 is equal to 4. And hopefully you can see that that means my distance in is equal to 8. And I have to have some units here. So this is in meters. So this has to be meters. All right. I'll do the other two on a separate screencast.